by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to your host.
Ladies and gentlemen, welcome to another episode of Cosmic Catastrophe on Revolution.radio, the #1 listener-supported internet radio. That's pretty damn good. I'm your host, Diamond, and this is my lovely co-host, Leah Shaper.
Hello.
Welcome to the show. Today, we're going to have a fantastic show. The title of the show is Expansion Tectonics versus Plate Tectonics, the Expanding Earth Hypothesis. And it was kind of like studying for a final exam on this one. The only difference was I wasn't going to get graded.
Yeah, there's a lot of information and very interesting evidence out there, and it does take a little time to read through it.
Now, what's interesting in doing this independent deep dive in this study on the topic of expansion, the expanding Earth hypothesis, or expansion tectonics, whatever you want to call it, is that we don't know anything about the Earth. Since the 1960s, we all believe that plate tectonics is some kind of like a law of nature, a law of geology. When you look into the topic, very little is known. And by the end of this podcast, you're not going to believe anything that has to do with plate tectonics, potentially, because there are so many other options and so many other questions that need to be answered.
Yeah, and the biggest issue with plate tectonics is that the driving force, the mechanism, is not understood at all. And the mechanisms that have been proposed have issues.
Right. So just in general, as a geologist, I can sum this up to you. Like when I'm teaching Geology 50, what we were teaching decades ago is that there is some sort of convection currents deep in the mantle that are like rollers that force plates in different directions. Modern tomography and other techniques, when we now look through the Earth, we don't see those convection currents at all. We see these huge three-dimensional prominences that are coming out from the core, which would preclude the presence of these convection currents. So there's a big disconnect between the theory and the pictures and what we actually see. And then that brings us to the expanding Earth hypothesis, because if you're just going off of observational science here, there's a really good case that the plate tectonics theory is bunk and that something else is afoot, and it's very spectacular. It's almost scary, and maybe they don't want to even consider it. But according to modern geologic understanding, what I was taught at university, at one point, actually several times in all of geologic history, Earth had all of its land combined on one single supercontinent. The most recent one that you've heard of is Pangaea. And this continent would have been sitting on one side of the giant Earth that we live on, which is pretty nonsensical. Because what we'd have is an ocean floor that is bigger than all of the continental masses by 5 or 8 fold. Yeah. And you'd have
a very unbalanced Earth.
You'd have an unbalanced Earth. And this is basically the theory, the plate tectonic theory. Now, if we go back before Pangaea, there's Gondwana land, which is part of Pangaea, but Gondwana land is every piece of land now. There's not a single piece of land on the entire Earth except on this supercontinent.
Yeah.
That's ludicrous. Just the thought of it is ludicrous. We're going to show you some pictures later of what that looks like. But this is plate tectonic theory. Now, part of plate tectonic theory is also that there's mid-ocean ridges, which we know exist, and there's seafloor spreading happening on it. So there's equal amounts of plate being produced on both sides of these expansion zones. You can also you don't have to call them mid-ocean ridges. They don't have to be seafloor expansion. They can just be rift valleys, rift zones. When you pull two parts of the crust apart, it's called a rift. A big crack forms. That crack can go all the way down into the mantle, and then magma shoots up. This is what's happening in Iceland. This is what's happening in the Rift Valley in Africa. This once happened on the east coast of the entire US. There are these huge inland basins called Rift Valley lakes where there's all these dinosaur bones and footprints that formed when the proto-Atlantic was pulling. When Africa and the US were pulling apart, these giant cracks formed and they filled up with mud. Miles worth of it, up to 12 miles worth of mud in just tens of millions of years. So these are deep cracks.
Yeah, yeah. Well, and then, you know, I mean, we'll get into this, but there's the issue of if we have the seafloor spreading in these rifts, such as the Mid-Atlantic Ridge, and if the Earth is a constant size, then where is the rest of that material going? And one of the things that we find, and this is the issue here, is that there's not enough subduction anywhere to account for all of the seafloor spreading in order for Earth to remain the same size. This is a huge problem.
Yeah, because if we just go back to Pangea around 500 million years ago, let's just go back 300 million years ago to the very end of Pangea. What we have is a 6 times that landmass, which is now ocean, which needs to go missing in just the next 300 million years. And there is, just like you said, not enough subduction. So the whole idea is that the same amount of rifting is going on, there has to be the same amount of subducting going on, and there is not evidence to support that.
I mean, there's a whole host of other problems too. I'm not going to get into the nitty gritty of this, but I read this very interesting paper written by a guy named Degazel Marvin, that kind of covers like all of the expanding Earth issues with plate tectonics and the history of these theories and blah, blah, blah. But, you know, if you look at the directionality of how continents are spreading and the rate at which they're spreading, there's all kinds of other issues that arise in contradictions that plate tectonics just simply can't explain.
Yeah, and we'll get to that in more detail, including that paper. But first, we're going to cover the whole thought process. Before, let's say, right at the turn of the century, in the late 1890s, prior to that, there was very little geology going on. You know, this is the heyday of geology. They're just finding fossils. They're coming up with ideas up in Alaska about catastrophes, and they're trying to match it with the Bible. So everything is kind of a little mishmashed here. But so first, we have the expanding or growing Earth hypothesis, which we're going to pretty much convince you of by the end of this podcast. It argues that the position and relative movements of continents is due partially to the volume of Earth increasing. And back at around 1890, they also had the idea that it could possibly contract. So the Earth could either expand or contract, like contracts from cooling and expands due to thermal expansion. This was all explainable through physics, and they just threw out that general idea. It wasn't until 1889 and then 1909 that Roberto Mantovani actually published a hypothesis of Earth expansion and continental drift, which is kind of both theories combined. You know, it's a little of plate tectonics and a little bit of the Earth expansion hypothesis, which is kind of interesting. Now, there's no real solid scientific evidence until the last few decades to support an Earth expansion or even plate tectonics. So once we started looking at the magnetic reversals on the bottom of the Atlantic, we then got a good idea that there is plate motion, and then the whole plate tectonic idea exploded, so to speak. Can you add anything?
Yeah, well, I mean, I think we should get into the measurements on the seafloor, right, of the magnetism, because that's the evidence that the seafloor is spreading, right? So as the seafloor is spreading, you get these areas of magnetic reversal, right? So which shows that like, and do we have a picture of this? There is a picture of this in the Marvin paper. So we'll see these stripes on the seafloor that line up with magnetic reversals through time. And so you can actually see the spread. So this is just proving to us that...
Can you see the screen? Are we sharing?
Yeah, I can see the screen.
All right, so we're looking at a simple jiffy of what an expanding Earth would look like. It's going to start with all the continents together there, and there's some little rifts that form, and then the oceans spread. So this is just the general concept of the idea.
Yeah.
Now, before we get into a little video I have, we're going to look at this isochron map here. So it's only in the last few decades that we have resolution that is this good to be able to look at all the seafloor. And this is colorized by geologic time. What you're going to notice is that at the main mid-ocean ridges, or the mid-Atlantic ridge here, and then the mid-ocean ridge in the Pacific, which comes through Baja and down, the crust is 0 years old.
Yeah.
It's literally where the rifts are forming new crust. And if you move out in the Atlantic mid-ocean ridge through yellow, which is 60 million years old, that's going to show you that in the last 60 million years, the Atlantic has spread to double its size.
Yeah.
That's
and then you get all
significant.
the way to the blue layer, and the oldest that you're going to find is 180 million years. So if the Earth is 4.5 billion years old, why is the ocean floor only 180 million years old at most?
And that's an interesting question. As a geologist, I'll answer that. Survey says that the oldest crust is the continental crust, and some of it dates to 3 billion years old.
Yep.
But none of the seafloor.
Yep.
And so that leaves us a problem, because if we just reverse the rifts on this map, which are the mid-ocean ridges, if we reverse them through geologic time, something very interesting happens.
Mm-hmm.
And I'm going to show a video here, which you can't see on the radio, but this is just 10 million years of reversal in those rifting areas. The Pacific itself shrinks at an astounding rate.
Mm-hmm.
The Pacific is the same age as the Atlantic and is 3 times as wide.
Mm-hmm. And apparently is expanding at a much faster rate than the Atlantic is.
Yeah, 3 times it would assume. So look here, I'm going to pause this at 40 million years. Take a look at that. Take a look at how little ocean there is on Earth.
Yep.
And so we're just reversing using those isochron maps. Here we're back 60 million years. The Earth is less than half the size it is now.
Mm-hmm.
And so therein lies the problem.
I have some interesting figures. Actually, this Marvin paper does some rough calculations, and essentially what he comes up with is that the current volume of Earth is 355% times greater than it was 180 million years ago. The radius is 152% greater than the radius 180 million years ago. That's a huge change.
Yeah, well, we just watched the video representation of that change, and the isochrons cannot lie.
Yeah.
That's what's interesting.
And the growth rate is like 1.22 centimeters a year.
Well, let's talk about that.
Yeah.
So it's kind of interesting. I just read a paper. There's a lot of people that have debunked expanding Earth, because they're plate tectonics hanger-oners. It's just like a climate cult. This would be the plate tectonic cult,
Well, to be fair, like at first blush, the idea of expanding Earth does sound kind of preposterous. But if you actually take a moment, like you only really need a moment to look at the evidence, it's very convincing.
Yes. And we were talking about this, like everyone believes in the Big Bang. Everyone believes that the universe is expanding.
Right.
We all know that galaxies go from small to large. They expand.
Suns expand.
And so how did they create stars? They're not sucking them all in. There is spontaneous generation of matter along filaments in the universe. We know this. We've even imaged it. And so mainstream science has a long way to catch up.
Yeah. I mean, if everything, the point is, is if everything is expanding in the universe itself, galaxies, suns, why is the Earth the only thing that's not expanding? It's the same issue I take with flat Earth theory, right? Like everything in the universe is round and spherical except for Earth. Okay, that doesn't
So
make any
are you
sense.
saying that plate tectonics theory is the same as flat earth theory?
Guess I am. Oh gosh,
That's
I'm
the
gonna get nailed
transitive
for that.
property. Now, what I think is going on here, which is kind of interesting, is a number of things, because the early studies, and when you study physics, show that thermal expansion is a thing. When you heat something up, it will increase in size. When you cool it, it shrinks.
Mhm.
Now, but we're talking about more than tripling the volume in just a short period of geologic time. 160 million years isn't that long ago. It just brings us back towards the beginning of the dinosaurs,
Mhm.
but it explains how for 150 million years, as the Earth is expanding, the dinosaurs could have survived.
Mhm.
And during this 150 million years, as the Earth is rapidly expanding, the dinosaurs are getting bigger and bigger, which is interesting.
Yeah, yeah, that is interesting. Very interesting. Um, I saw one hypothesis thrown out there that, the dinosaurs would have been able to survive had they actually been living in water instead of living on land. But that seems like a much more complicated hypothesis than suggesting that the Earth being smaller, resulting in, and I'm going to say in quotes, gravitational force being less, making it easier for dinosaurs to survive on Earth. That actually makes more sense than suggesting they were all living in water.
Right.
And
And that water can just go into a much thicker atmosphere. When you shrink the Earth, your atmosphere can be very thick.
yeah, yeah. And I don't know this for sure, but I'm sure that the biological fossils would strongly suggest which species were living on land and which were living in water, and we probably can't refute a lot of that.
We can't, but here's what's interesting, geologically speaking. First, let's take a look at some of the global sea level graphs to bring us up to speed. Today, and back when the Earth was all the continents were connected, look at that. It's the same cold period. It's the only time we were in an ice age, was back when all the plates were connected. That's kind of interesting. It's also when CO2 was as low as it is today, the only other time.
Huh, that is extremely interesting.
And you could see it here on the graph. Here we are in an ice age now for the last several million years. And this ice age, when all the Gondwana land here, period, Pangea, before the breakup, this was an ice age that lasted for 40 million years.
Well, that's interesting too, because wouldn't you think that if we're talking expanding Earth and the Earth is contracted enough so that the continents are connected, wouldn't sea level be a lot higher?
I have this. Yeah, you would think so, but it's lower. So the
Huh.
water's going somewhere. It's going into the atmosphere.
Huh.
But what's interesting is that what is this actually a measure of sea level? I don't think the proxy data is actually measuring something good. Now, let's take a look at this. This is the model that shows, let me see if I can open this up and if it gets any bigger. So if we just reverse back into the end of the Cretaceous and Tertiary, the end of the dinosaurs, from that period all the way back to about 400 million years, we have this supercontinent. And we have no oceans on Earth because the whole Earth is all continent.
Yeah.
But what we find in the fossil record for that entire time period are inland seas. All of the continents are covered with shallow oceans.
Mm-hmm.
So that's interesting.
Yeah. Yeah. I've even seen the hypothesis that it's possible that at that time most of the water was largely fresh water, that it doesn't become salt water until the continents start breaking up and the water is exposed to the sublayers that are more salty, which is interesting.
Yeah, well, and that makes sense because no, I've seen reef complexes all over the United States. So geographically, they were everywhere at one point or another. But that's very interesting because if there are these shallow inland seas, you're going to get all kind of different types of basins and freshwater and saltwater mixing, especially if this rifting is occurring.
Yeah.
like in the Gulf of Mexico, there are miles of salt deposits. These were deposited, according to the most recent peer-reviewed studies, at around 200 million years ago when Africa was breaking apart. And they said that the oceans were running into the rift and, evaporating.
Interesting.
But what might have been happening is salt forming from the crack in the earth, so to speak.
Yeah. Yeah.
But the geologic evidence shows that from 220 million years and earlier, most of all the continental crust on Earth was covered with shallow inland seas.
Yeah.
There's brachiopods, there's clams, there's all kind of marine fauna.
There's marine fossils everywhere, right? Like every mountain range has marine fossils. Like they're literally everywhere all over the planet. People always wonder why they find shells in the mountains. I mean, we find them here all the time.
Right.
But
And they start around,
it's not unusual.
They start at the Cambrian explosion and they go all the way up towards the time of the breakup of these supercontinents.
Yeah. Yeah.
And then we start to get real oceans, and the inland seas tend to go away. Although we do have some geographic areas we could call inland seas, like the Bahama Bank, you know, because during the, before the Holocene, the Bahama Bank was above water. Yeah.
Well, also, the Mediterranean basin is the only oceanic floor that is older than 180 million years old, right? So that's probably an inland sea, an ancient one.
Yeah, exactly. And a remnant of it, and still there.
Yeah. Yeah.
All right, so let's go over a couple of the ideas on what could make the Earth get bigger.
Yeah.
Now, the first idea is expansion with constant mass. And so if you get expansion with constant mass and you took a basic physics course, what's going to happen to the Earth? Hello?
What are you asking?
Can
you just answer the question?
Hypothesis is expansion with constant mass. So if the Earth gets bigger and it has the same mass,
right, then
what
the density
does that
goes
mean?
down. The density
Earth
goes
is going to become a styrofoam ball. Yes.
Yeah. Yep.
It'll become a ping pong ball.
Right.
And that, we'll get into this next week, maybe. This helps with some of the hollow Earth theories.
Well, you know, I also saw somebody pointed out, like, if you go with that idea that the mass is constant, so the density changes, if you reverse it and you go back to the contracted Earth at 180 million years old, you have a problem, because the Earth density would have to be 40 grams per centimeter cubed. However, one of the heaviest elements on Earth is osmium, which is only 22 grams per cubic centimeter.
Yeah,
so we have a problem there. That doesn't work.
A shovel full of dirt would weigh 800 pounds.
Yeah. That's
okay.
That's a problem. That's not reflected in anything on Earth.
Right. And based on that problem, expansion with constant mass is probably not happening.
Yeah.
The most logical idea is mass addition. And Leah, and I talked about cosmic dust. There are 5,000 tons of cosmic dust falling to Earth each year. So there's definitely mass addition just from cosmic dust.
Well, and there you have another problem. And actually, the estimate that I just looked at was that the cosmic dust is 40,000 tons a year. But even with that, even if that is correct, we're losing 95,000 tons of hydrogen and 1,600 tons of helium from the atmosphere every year. And that essentially equates to the mass actually shrinking just a smidge every year.
So the surface mass budget of Earth, based on the parameters we know, is actually losing mass.
Right, right. So that doesn't really solve the problem either.
No, but we can clearly state, and the reason people stay away from Earth expansion hypothesis is that there is absolutely no mechanism of action that can be proposed for the addition of new mass.
Yeah. And
I mean,
even if
you could say impacts, periodic impact, but you would obliterate the whole planet, and we don't see that.
Well, and I have another interesting figure about that disproves that concept, right? So let's say we had daily impacts over the last 180 million years, and each of those impactors was like a kilometer wide.
Oh, save it. Let's go to commercial.
Okay, all right.
All right, when we come back, we'll talk about how we cannot be growing because of impactors.
Listening to Revolution Radio at freedomslips.com, and we'll be right back after this message.
Who owns you? If you're not in control, then someone else is. Join me, Ivy West, for Voices on the Wind, Saturday. I discuss government, health, metaphysics, suppressed science, universal mysteries, little-known incredible facts, alternative energies, and even more than you can imagine. Won't you join us on Revolution Radio Saturdays for Voices on the Wind with me, Ivy West.
There are lives in the balance, people under fire, children at the cannons.
Because if your head's in the sand, your tail is a target.
Thank you for listening to Revolution Radio at freedomslips.com, the #1 listener-supported radio station on the internet. Please help support this station so this battle can continue forward. Revolution Radio!
There have been imaginative science fiction writers for generations.
Be evasive.
But that doesn't mean that they're telling the truth as opposed to fiction.
I'm aware of some archaeologists that have uncovered large bones indicating giants in Virginia. Genesis chapter 6, verse 4, there were giants in the earth in those days, and also after that, when the sons of God came unto the daughters of men, indicating that there were giants before the Nephilim.
And sons of God, plural. They weren't talking about Jesus coming down and
No, that's right. Yeah. Uh-huh.
I'm Steve Crawford. Join me every Thursday night in Studio A at 6 p.m. Eastern for Factor Theory Live. Find us on www.revolution.radio. Great guests and great stories. What do you believe?
Join me on the Brian Rouge Show on Revolution Radio, Eastern Standard Time, every Tuesday night from 6 to 8. We talk about the four most vital things, in my view, affecting all of humanity. Number one is UFOs and aliens and their agenda for the advancement of humanity. Number two is the Jewish establishment's control over all aspects of human civilization. Number three, the truth about Adolf Hitler, how he was the opposite of what we've been told. Number four is advanced ancient global civilizations. Join me on the Brian Rouge Show, Tuesday nights from 6 to 8 on Studio B on Revolution Radio.
Thank you for listening to Revolution Radio at freedomslips.com. Any commercial advertising you may hear in this program is of the sole discretion and benefit of the host of whose program you are listening to. Revolution Radio does not endorse any commercial products, nor does it accept monetary compensation for on-air advertising of commercial products, nor will it ever. We are and shall remain 100% listener supported. Any product advertising on this program are considered used at higher risk, and Revolution Radio shall not be held liable for any claims or damages received from any product advertised within this program. Revolution Radio, where information never sleeps. The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and FreedomSlips.com, its staff, or affiliates. You're listening to Revolution Radio, FreedomSlips.com, 100% listener-supported radio, and now we return you to your host.
Welcome back to the second half of Cosmic Catastrophe on Revolution.radio. The topic is expansion tectonics versus plate tectonics, the expanding Earth hypothesis. And we were just touching on some of the ways you can expand Earth and some of the reasons why that's probably not happening. We were just talking about mass addition, adding mass. There's no real mechanism except cosmic dust. And the amount of cosmic dust doesn't even equal the amount of atoms that are being sheared off into space.
Yeah.
So that's probably not the answer. Then we were touching on asteroids. And
Yeah.
I said you would need to obliterate the whole Earth to even make it possible.
Well, and even if you consider obliterating the whole Earth, right, getting a daily impact of a kilometer wide every single day, you'd still end up with an Earth that's 25% less the size than it is now. And obviously, we're not getting impactors a kilometer wide every day. That's not happening. Then you could consider one giant impactor at some point. But if you do that, then you would have to have some moment where the Earth suddenly expands, right? Not this constant process. You could also consider.
Well, and if it was that big, everything would die.
Yeah. Yes. Yes. Right. That too. There's all kinds of problems with that. And then we also touched on this already, right? Like if the volume of Earth is increasing and the mass is conserved, that's an issue for the reasons that we stated earlier, that if you reverse it, the contraction of Earth would mean that the density would be so high that it far exceeds any element that is on Earth. So that doesn't work. But the other problem is if you're looking at it like a sun, right, you've got this heating and you've got this buildup of pressure that's causing the sun to expand and all of that. But then with Earth, you also have a compression factor. And so that's going to bring things to like a liquid state, or even if the pressure's high enough, a solid state. Otherwise, you're going to be violating thermodynamics. So that doesn't work either.
I can fix it all. There is one theory that physicists can accept that would allow for this hypothesis to be correct. And it is the decrease in the gravitational constant in our solar system. So Paul Dirac in 1938 suggested that the universal gravitational constant had decreased during the billions of years of Earth's existence. So this is changing physics as you know it in the solar system. Mm-hmm. And as the gravitational constant decreased, everything expanded.
Yeah.
So did you read any of that?
No, I didn't actually, but I get the concept.
Yeah, so measurements of a possible variation in the gravitational constant shows an upper limit for a relative change of 5 times 10 to the minus 12 per year. So it's plausible that the gravitational constant could have changed. Now, I don't know if that supports the dinosaur hypothesis standing on land, but it probably does.
Well, and then, you can also consider hollow Earth theory, right? I haven't gotten really deep into this yet, but it would be one way of explaining an expanding size without all of these other problems that we talked about. It would mean that the shell of Earth is only 664 kilometers wide, but then you do have to reevaluate gravitational theory in order for that to work. Right? Because you no longer have this solid ball.
Yeah. Well, there is an idea, and I think in the future will be the correct answer. We saw with the Sapphire Project, which is a group that created an artificial sun to prove the electric sun model, that what they were able to do with just a few simple elements inside of a vacuum with a plasmoid is to transmute elements, which means they created elements that were not there using energy. Mm-hmm. And so that same energy is coming in through the Earth at the auroral belt. And we know that muons heat the subsurface, but what if this plasmoid energy that's coming in at the auroral belts is also transmuting elements at the core?
I also read a consideration of that concept, and the issue that was raised, and apparently, what's his name? Samuel Warren Carey, who was big into, really kind of got the Earth expansion idea going in like around 1956 and 1976. He did some conferences around this and wrote some papers. And he also proposed this, like the mass is being generated at the core of Earth. But it does sort of run into some other problems, right? Because when you generate mass from energy, you're starting like with neutrons, but they'll quickly decay to protons and electrons. And so I don't know, there's maybe an issue there too. And I have to get deeper into that to really evaluate that. And I haven't done that.
But what do we really know?
Yeah. What do we really know? Good question.
Now, according to paleomagnetic data, they used that to calculate Earth's radius 400 million years ago.
Okay.
And it was 102 plus or minus 3% of the present radius. So it was the same. They calculated it being the same.
Interesting.
That's based on maybe false assumptions and the paleomagnetic data.
Yeah.
Because you can't get that specific that long ago. Now, NASA set out to disprove this theory also. Let's share the screen back again. And can you see the isochron map?
Yeah.
So they set out to prove, because we have all this specific instrumentation, they went out to prove that the Earth is not expanding. And guess what they found out?
That the Earth is expanding?
Exactly. But they used it to disprove that it's expanding. All right, I'm going to tell you here. The final result, using all the high-tech GPS and eliminating any drift or any noise, the scientists found that the Earth radius changed by 0.004 inches, which is 0.1 millimeter per year. That is an expanding Earth. And maybe we're in a phase of low or no expansion.
Well, I saw another evaluation of like the isochron data that actually suggests that expansion is accelerating. Like it's not even constant, that it's actually speeding up.
And so maybe it's the magnetosheath that keeps our shape. So as the magnetic field weakens, we start to expand more rapidly.
And this is like one of the big questions that I have, right? So if Earth was the same size up until 180 million years ago, then what triggered the expansion? And I have huge questions about that. And I'm just going on instinct that it must have something to do with the electromagnetics and the dynamics with other forces in our universe. And as you just suggested, maybe it has a lot to do with our magnetosphere. Speaking of paleomagnetics, this is a little bit off of what I just said.
The biggest extinction in history that everyone's talking about, this Permian extinction, is when all the continents break up. The very beginning.
Right. So
if you crack the Earth on all these plate boundaries, the volcanism and the gases alone, there's a major SO4 spike. Everything gets choked to death.
Yeah,
that's basically what happened.
Well, and even if that's not happening so rapidly that it causes those kinds of problems, I would guess that there's still something electromagnetic that is rapidly changing that is affecting life on Earth.
Yeah, indeed. And it's cause and effect. So it's just like when we always say it's a cocktail of things. The electromagnetism changes something, Earth starts cracking up, then there's more volcanoes, and there's a multi-layered effect, and that's how we get these mass extinctions and speciations.
Yeah.
But what I think is so undeniable here is the Atlantic Basin.
Mm-hmm.
There was no Atlantic Ocean about 100 million years ago. There was an Atlantic River.
Mm-hmm.
It's interesting. And most of the Pacific is missing as well. if we all of this part of the Pacific here is not there 60 million years ago. It all reverses back into there.
Yeah. Yeah. And what's so interesting too, and I'd like to get into this a little bit, like, okay, the Pacific's expanding so rapidly, like something like 3.5 times the rate of the Atlantic. The expansion is not constant all around Earth. And I mentioned earlier, there's issues with there's not enough subduction, right? So
yeah, let me point that
supposedly-
out. Let me point that out on this map. So the only subduction zone that we can point out here is around the Ring of
Ring
Fire.
of Fire, exactly.
That's it. There's
So
a few other proposed subductions up here on the plates, like where the Himalayas are and where Africa is pushing up here in the Mediterranean.
Yeah.
But there isn't enough subduction zones to suck up all this seafloor to keep Earth constant size.
Right. And so how is the Pacific expanding at such a rapid rate, but also subducting at an even greater rate to account for all of the other expansion in other parts of Earth? Additionally, there's no real good evidence of subduction in the sense that if you take a seafloor and you're shoving it under another plate, there's going to be all of this like loose sediment on top of that. So you should have piles of loose sediment at the subduction zones, or even like folding that's occurring, right? Like if you try to shove a tablecloth under a placemat, it's going to get folded and crumpled and stuff, and you're not seeing that.
Yeah, that is telltale. All you see is volcanoes inland, and they're explaining that as the melting seafloor.
Yeah, yeah, and we should also mention too, with expansion occurring at different rates depending on where you're looking at the globe. This idea of like the orange peel effect. I don't know if you have a photo available of this at the moment, but if you have
that's the paper.
Yeah, the Marvin paper on page 11. There's just a good little diagram of this. So it's kind of like the hinge point of expansion is somewhere up near the North Pole. And you have sections of the skin that are separating away from each other, but more so at the base, which you actually see evidence of with Antarctica, right? You have a lot of expansion occurring around Antarctica. You have more expansion in the southern hemisphere than you do in the northern hemisphere. So it's not like, it's not like it's blowing up at an even rate everywhere. It's like some areas are more subject to this movement than others. Go to page 11 in that paper, and you'll see it.
I couldn't find it. I clicked on everything but the right page. So there it is. There's that orange peel effect.
Right. And if you look at like the rates of expansion of all of these plates in various parts of the world, it lines up with movement like that orange peel thing. So pretty interesting.
Mario Build Reps points out that these mid-ocean ridges surrounding Antarctica are the main reason for this effect.
Yeah. And if I remember correctly too, like Africa, it's a sort of similar with Africa. You have more expansion on the edges of Africa than some other places.
Now, just in general, thinking critically, what are the odds of there only being seafloor that is 300 million years old on a 4 billion year old planet? 5 billion.
Well, right. I mean, I don't know how to calculate.
We have
odds.
crust, continental crust that's that old, 3 billion and older, lots of it. Anytime, like in the Grand Canyon, you go all the way back to the bottom of the sedimentary stack, you hit the basement rock. It's 1 billion years old. Philadelphia is sitting on 1 billion year old rocks where the mountains have eroded.
Right.
But we don't have any billion year old seafloor.
No, we only have 180 million years old and however old the Mediterranean basin is, and that's it.
And prior to that, there's evidence that oceans were all over all the continents.
Yeah. just on that logic alone, it really says that we have to be expanding, right? There's no other explanation. I mean, I just can't see it any other way now, which is so interesting. But again, I keep coming back to this question of like, what triggers the expansion?
So let's go look at the ludicrous plate tectonic theory here. Here is Gondwana land, where the entire other side of the Earth here, which we can't see, is all water.
All one ocean.
And here is another version of that, where the whole other part of the globe is ocean.
Yeah. Which
Does
presents
that seem even plausible? Could the planet even rotate in this scenario?
Yeah, I mean, that's a huge problem, right? Because the oceanic crust is much thinner than the continental crust. So generally speaking, you're talking about a lot less mass on one side of the Earth than the other, or even a small section of Earth that has like all the mass. And so how are we going to spin in any way that's sane? That's like a top that's just
It
going to
has all the
topple.
mountains and all the crust. It's 4 times thicker on average. It's absolutely ludicrous. We would wobble off our plane of existence out into the far stretches of the universe.
Yeah, we would just be like spinning around wildly and flipping all over the place.
So, and what's even more fascinating is how recently everything was connected in geologic time.
Yeah. Yeah. Well, and then there's another question in here, and you've mentioned this, and I've read this also, that there's some evidence, and I don't know a lot of this, that we have also maybe contracted again, that continents have come back together a few times. I don't know much about that, but that's an interesting suggestion as well. Like, are we expanding and contracting?
We'll end on the ludicrous idea of supercontinent 101, a short course. So you have Pannotia, Gondwana, Pangaea, and they begin by describing all the plates and all the directions of movement. And they don't then explain how impossible it is to suck up all of the missing ocean under these subduction zones.
It also does not.
But
it also doesn't explain, like, if you look at the biological evidence, the fossil records, right, you'll see similar fossils where supposedly continents didn't connect because they weren't all connected, supposedly.
Yeah.
So that's a problem.
If you reverse the Earth,
right? So like the boundaries of
what they're
Eurasia,
saying is that the animals on this side of Eurasia are also found on this side of North America.
Exactly, stuff like that. And this like particularly applies in the case of, if I recall correctly, like Antarctica and South America in some places. Yeah. So that's a problem.
In order for this to happen, you have to have an animal swim, 12,000 miles across the giant ocean.
Right. So that doesn't work.
Yeah, so this is basically the idea. There was a supercontinent that was short-lived at the dawn of life. In the Precambrian to the Precambrian, there was a supercontinent that lasted from 633 to 573. 573. So that's about 60 million years of a supercontinent. And then it broke up just for 20 million years. So the idea would be that this is the first supercontinent is the small Earth, and then the Earth expands. It expands from 573 to 550, and there's some oceans form, and then it shrinks again back into one solid supercontinent with no oceans. And this would be Gondwana, which lasts through all of biological history and evolution from 550 to 150. This takes us all the way up through the dinosaurs, plants, amphibians, everything's on Earth at this point. And then about 200 million years ago, it starts cracking up. The expansion happens again. So there's an evidence for at least one period of slow expansion and then a contraction, and now we're in a bigger period of expansion that's now been going on for 200 million years. The first expansion episode was just 20 million, and then we shrunk back down. So it probably didn't get that big. It was like a test, maybe. And now we've been expanding for 200 million.
It's so interesting. And again, I just keep coming back to like, what is the trigger for the expansion and the contraction? And one thing I've considered is kind of like a Velikovsky idea, right? That our solar system has changed over time. And so maybe the dynamics in our solar system, particularly the electromagnetic dynamics, maybe that has a huge impact on what's happening on Earth. I don't know. I mean, it's just a hypothesis and total speculation.
Yeah, it is fascinating. But what the biggest problem that I have with the whole idea is that all of these plates come together, the continental plates come together in a big island. What are the odds of them doing that? Because it is the majority of geologic time that we are in this supercontinent mode. Is it that they all accidentally meet on one side of the world? Or is it more likely that if we reverse all of these, that all of this is what the Earth looked like?
Well, and that makes a lot of sense, right? Because if the Earth is the same size and all of the continents move together, back together again, it does seem like it would just be by chance that they would end up in the places that actually fit. However, if the Earth itself is shrinking, then it forces continents back into those positions.
Yeah,
where else are they going to go?
Exactly. And so they don't rotate around. There's no rotating plates. It's straight out and straight back in.
Yeah.
There's very little changes. And the mountain ranges we get are from that first expansion in 550. There are things called orogenic belts. Then we know when continents supposedly hit back together, like when Africa smashed into North America, that was during the first Paeonia expansion during the Cambrian. Boom. Then we have these Himalaya-like mountains.
Right.
And it's just so interesting that all of the geology still works with the expanding Earth model.
Yeah.
It like doesn't destroy what we know.
Yeah. Yeah. And then it also still allows for things that we do see evidence of now in our current state, like India, is moving north into Asia, and it's also rotating. So that's kind of interesting. And like that can happen, right? Because there's space for it. But if we were to fully contract, it would probably rotate back into whatever position it fits into.
Right. Now here's the smoking gun. On the east coast of the United States, which is a passive margin, there's no subduction, we have folded rocks. Those folded rocks match the folded rocks of Africa on the other side, which is another passive margin where there's no subduction.
Yeah.
So if you reverse the two back at the mid-ocean ridge, the continents slam into each other and fold the rocks.
Mm-hmm.
What's not happening under the so-called subduction zone is the slamming into.
Right. Right.
So
and
they're claiming that plate is just neatly sliding under a continental plate and
without leaving any debris on the surface in piles or anything like that.
And there should be at least a wedge of super compressed metamorphosed rock.
Mm-hmm.
Yeah. Think of the pressures involved.
Yeah.
And then as you get down, so there's lacking geologic evidence because on that subduction zone, the subduction zone around the Ring of Fire, it would have to be shooting in there at a very high rate.
Yeah.
To keep the Earth the same size.
Yeah. Yeah, extremely high.
It doesn't appear to be happening. There would be constant volcanic eruptions on that zone.
Yeah, the Ring of Fire would be on fire at every single second.
Literally from the friction.
Yeah. Yeah. Yep.
So what does it mean for our future? Will the Earth contract again? Will it expand? It appears as if these expansions may happen on geomagnetic reversals or excursions, and we're going into one. So, and that might just, that's why there's all this increased volcanism. Even if the expansion slowly increases, you're going to get more volcanism in Iceland, on mid-ocean ridges, etc.
Yeah.
And so that's just fascinating to think about.
Indeed it is.
Yeah, so what's happening maybe in these massive, like the Permian mass extinction, when the Earth starts spreading, when we were first all continent, we start spreading, there is so much volcanic activity. The Earth is in such an uproar during a magnetic excursion while extinction is happening that across the boundary, you get a completely unique set of animals and creatures unlike anything prior to it. It's because the world, look at this picture, is becoming something unlike anything it ever was.
Yeah. Yeah.
With massive oceans.
Yeah. And potentially, quote unquote, gravitational force change. And I'm saying quote unquote, right? Because the problem with gravity is that we don't know what it is, right? We just measure this force, and that's all we know. We say that it's connected to mass. and we can do some calculations with that, but that doesn't mean that it is a force of mass. So what is it exactly? It may be something like a byproduct of electromagnetism. But clearly, if we have a much smaller Earth, whatever that force is going to be smaller. If the mass is actually smaller, if that calculation still holds up, which is another question.
Yeah, but the isochron map doesn't lie.
No, it doesn't. It's so interesting.
Let us know what you think in the comments. You can watch this podcast later tonight on Magnetic Reversal News, and we love
YouTube.
Yeah, on YouTube.
Listen to Revolution Radio at freedomslips.com, and we'll be right back after this message.